Okay, so in the previous video we discussed about the equilibrium constant and its unit, and equilibrium constant was Kc. So here we'll be discussing about the importance of equilibrium constant. Alright, so Kc is not only calculating constant. Like what it was calculating the ratio of reactant to the product. So the Kc is not only for calculating the constants like the concentrations, but also direction and extent of chemical reaction. Okay, so what does I mean here? Kc not only tell us the calculating constant but also the direction and extent, mean strength of the chemical reaction. Now how do it tell us the direction and strength? Let me tell you. Just give me a minute. Direction of chemical reaction. Alright, so let's see how Kc tells us the direction of the chemical reaction. So first of all, you need to understand Kc, that is equilibrium constant, and Qc. By comparing this, we will get the direction. Now what is this Kc? It is basically the ratio of real concentrations. Don't mix them up. It was the equilibrium constant, and it was showing us the ratio of equilibrium constant terms. Alright, but here this ratio is real concentration, or you can say this is known as the reaction quotient. Reaction IENT. Alright, so here let's compare this, and by that we can get the direction of equilibrium chemical reaction. So first of all, if Qc is equal to Kc, so when the both of sides are equal, so what it is called? It is called equilibrium. So this is equilibrium state. Alright, when both of them Qc and Kc are equal. Right, talking about second, so if Qc is greater than less than Kc. Here Kc, let's suppose that Kc is reactant and Qc is reactant and Kc is product. Alright, so here this is less and this is greater. So what will happen when the product is more? Product is more, so reaction will be forward. You can memorize this by supposing that Qc is reactant and Kc is product. Alright, now talking about third one, if Qc is greater than Kc. So here the reaction the reactant is more. Reactant is more. So what reaction it will be? It will be reverse or backward. Alright, so by this, comparing both of them, you can get the direction of it, the chemical reaction. Now talking about extent of chemical reaction. Extent of chemical reaction. Okay, so for the strength, we don't need to compare Qc here, because we just need the strength, extent of the reaction. So here we have three conditions. By that you can know it. First is if Kc is very small, so what will be the strength? Then second condition I'll tell you. First of all, let's talk about this. So Kc will finish, here the reaction will occur and it will be finished. It won't be always continuous, it won't be dynamic here. And the maximum concentration of reactant, here maximum reactant, minimum product. So here this reaction will end, it is stoppable, end or stoppable reaction, it will stop. at one point. Alright, so now if we have maximum reactant, so here the reactant was maximum, so what was the like direction? It was reverse, so here it will also be reverse. Alright, second, if Kc is very large, so what does it mean? Maximum product and minimum reactant. Alright, so here the reaction was reversed, so what it will be? It will be a forward reaction. One more thing, it will never stop, it will be continuous, dynamic. Alright, so now let's talk about the third condition, that is if Kc is, are you able to see, is neither very large or small. So here this condition is stable, like it is not very much big or very much small, so what it will be? It will be equilibrium. So I hope this topic is clear to you.